I am associated with IDIA, and as it says here, and I'm also the CTO of ilifu. As Russ said, I quote designed the system, but I have many years of experience doing these sort of things. I was CTO for Compute Canada, which is a tier 1 computing organization for Canada for 10 years before coming here. So I've been doing this a long time. Ooh, that didn't do what I was expecting. Okay, so I'm going to talk about science gateways in general, talk about the Federation, and then go on to talk about the IDEA Science Gateway in particular, and talk a little bit about African Shared Computing Initiatives. So Russ has already mentioned one of them. So IDEA, I don't know if Russ really introduced IDEA, but it's a partnership of 3 South African universities, aims at capacity building in the direction of going towards the SKA, and also provide hackathons. So science gateways are used to bring together a set of web-based tools that usually support some particular community. And they generally, the communities are domain-based, with tools added to support their particular work and collaborations. So this is Cyber SKA that Russ and I were involved with 16 years ago now, and we're trying to deprecate it desperately because it's hard to maintain. And that's Nano Hub, which is a big nanotechnology science gateway. So there are many forms of federation, and usually you're talking about common authentication techniques, but more advanced systems also have common authorization systems. So the grid systems from the early 2000s, they had ways to provide these common APIs and services, but they were not at all user-friendly. They were really created by massive projects where everything was automated, and so you really just weren't supposed to use them as a user. And they got a very bad reputation because users tried to use the command line interfaces, and it really weren't designed for that. But now, with the improvement of the web-based federation tools, these are now becoming user-friendly. And usually authentication is provided by IDPs, identity providers, which could be university providers, or they could be from someone else like Google. They could also be Facebook, but don't use Facebook. This isn't being recorded, is it? Anyway. Moving on. As Russ said, we've been working with the EGI for some time, and the ilifu cluster became accessible through the EGI gateway about 5 years ago. And it became part of the EGI full cloud federation, production cloud federation, in 2022. And so most of the European open science cloud systems are accessed via the EGI Cloud Federation. And so if you look at a map of EOSC, you'll see Europe and one little thing dot down at the bottom of Africa, which is us. So EGI uses a tool called co-manage, which allows people to manage their individual research groups for authorization. And so that's really important because it means if a particular project gets access to ilifu and they get access to a system in India, then the owner of that project can either manage the people who can access those systems or delegate that to somebody else. So that means you don't have to keep on talking to system administrators. So it's a multi-level authorization approach where the system owner authorizes a project, and then the project authorizes the people. So this is what it looked like, getting in through EGI, going into our OpenStack front end, and just logging in. And actually, once I selected UCT on the EGI gateway, I then actually authenticate through the University of Cape Town. And so our system, well, EGI would never see any of my credentials. So this is how an identity provider works. So it just know whether I'd managed to authenticate with with University of Cape Town or not. And that could be any other identity provider, as long as it's one that's trusted. And then just when you get in, that's what it looks like when you get into OpenStack. And this is just showing the various management of groups, virtual organizations within EGI. This is where you could go in and manage your who can access your allocations. So for the gateway, so in fact, ilifu in one form or another has actually been around since 2015, which just happens to be when I arrived in South Africa, and when it just got its name in 2017. And so, we need to plan for supporting IDIA astronomers, hackathons, and some access to public data. And we also need to support some non-astronomy cases, which is bioinformatics mainly, and we just wanted to make it very easy to update the look and feel to support different communities and the tools as well. So then, high-level requirements, we want to limit the amount of code that we need to write and maintain. That comes from our experience with CyberSK, where with these things, you can usually get money to build them, but you can't get money to support them, and that's a huge problem. And then we wanted to minimize the amount of effort required to maintain user accounts, and that's where the authentication and authorization comes in, and facilitate the federation. Platform level, we wanted to provide single sign-on to best-in-class services. So instead of implementing new services, we wanted to just provide single sign-on to existing good applications. And then at the application level, we wanted notebooks, data visualization, file access, WAN, data transfer. So you've got to use the right tools to do wide area data transfers. You can't just use SCP or something. It just will be horrible performance for all sorts of technical reasons. Data delivery and account management. So I just threw this little diagram together on one Monday morning, and it just shows down the middle. Ooh, I don't have a trackpad. Okay. Okay. So what we look at here is services that are very simple. It could be run in a web server type thing, and then we have best-in-class services, and then we have ways of talking to the multiple IDPs up here. So that was something I threw together one Monday morning, and the following week, we had a working system, and this shows the difference between CyberSK, which took 3 years to write, and this that took 1 week to put together. So that's a big difference. And so we're using Django for certain things, front page, public data access, SSH key management. So that's one of the things that the public key management. So one of the things is a lot of tools are still not web-based. And so because we didn't want to have to support our own authentication system, we just want to use the IDPs, we wanted the users to be able to just log in using their IDP and upload a public key. So that means our system administration team are hands off this. It's all the responsibility of the organizations that people work for. And then we have ways of accessing the usage information and we had an initial container system, but I'll say more about that in a minute. And then we use this tool called Open On Demand to launch the authorized tools. And then the other tools we had is Keycloak for authentication and authorization, Jupyter for notebooks, Carter, remote visualization, Globus for one file transfer, and whatever it said down there. Oh, OpenStack dashboard. Okay, so that's what it now looks like. And you can go in through the system and get logged in using the identity provider. So I've gone in through UCT here. And then you get to this page. This is the jump page, so this is Open On Demand, and shows you all of these different tools and services that you can have access to. And I've already mentioned most of them. We have access to Slurm there as well. And yeah, we've got our container listings. And so yeah, that's just going in. You click on Jupyter, and you go straight to a Jupyter notebook without signing on again. Carter, go straight to Carter. And so a big point of what we're doing here with Carter is we're hiding latency. So by doing the heavy lifting on the back end and all of the rendering on the front end, you can interact with this very, very quickly, because you're not having to go back and forward to the server to do the interaction. You're only going back and forward to the server to get the big data chunks. So yeah, it's the Globus file transfer. Again, just click on it. It's not quite as smooth as some of our tools. Key management page for uploading SSH keys, and then the dashboard. And then we have an initial public data publication pages, but we're going to improve these somewhat. We're not really into the creation of data, so we're probably not going to take that too far. We really want to have other people doing that. And then the application catalog. So we had a simple listing of containers initially, but we're just going and getting S registry, singularity registry working. And that that's a really nice system, because Russ said we build containers for people, and that's true, we do that now. But with the S registry, people can put in their configuration, and it'll go through a build system and then install the container. There's all sorts of issues there about whether the container is trusted or not, but then S registry has ways of dealing with that, so it won't release containers until they're blessed by us to other people other than the people who built them. Then I'm just going to say a little bit about these shared computing projects. There's the African Open Science Platform, which has been planning for quite a few years, and Russ and I were involved in the initial planning, and 3 sites have been funded for that. I don't quite know how far they've progressed in actually getting them working yet. And then the South African Open Science Cloud, which Russ was one of the authors of, and I was quite involved in creating information for. And then NICIS, who's this government organization here in South Africa, published documents about this in mid-2023, so clearly it's on the roadmap for something to be funded, hopefully. And then what I've said here is the IDIA Gateway provides much of what is planned for the South African Open Science Cloud. It's, yeah, there's probably only a couple of things missing at this point, and they're only missing because we don't have the motivation to put them in yet, because we haven't got the federated partners, so it's things like data replication. We just don't have that yet. Then summary. So high-level requirements for the IDIA Gateway were actually developed over 6 months. I said that it was developed in a week, but we were playing around with lots of tools for about 6 months before deciding what we were going to do. And one of the aims was to provide this federated access to all of the ilifu services. And we're currently working with DARISA, which is part of NICIS, to ensure a common federation of different systems throughout South Africa, the different government systems. We're helping them to adopt the same techniques we're using. And we always, mentioned that real aim was to use best-in-class services. Didn't want to get back into this bottleneck we had with Cyber SKA, where we actually developed a lot of the services, and then we had to maintain them. And it's one of the problems that you don't necessarily realize when you start this is that because of security updates, the network managers, out in the NRANs, they won't allow you to keep systems running for that many years, and you have to actually update all of the underlying services to get all the security patches. And as you do that, you find that your higher-level applications, the interfaces change slightly, so then you've got a huge job to maintain these systems, and getting money to do that is very difficult. Yeah, looking to share federated access with BRICS partners. That's it.